Okay, so let's try this. All right, so we're going to start with this video. We're going to look at multiplying. All right, so when we multiply functions, essentially what we're doing is multiplying polynomials, right? We call them functions because they do exist in an equation form, and they have some kind of a purpose that's attached to a graph and everything, as opposed to just like random polynomials that you're like adding, subtracting, multiplying, dividing, all that. So in this sense, it's slightly more official, but it's basically the same thing, right? And so when we have something that says f times g of x, right, what that means is the same thing with adding and subtracting, is you're basically doing distributive property and figuring out what f of x is and multiplying it by whatever g of x is. Let's erase that so that looks nice. It's too early to start making mistakes like that. So so pretty much what we're going to do is we're going to take this and we're going to multiply it by this, right? So nothing wild here. And fortunately, something you guys have done, right? Which we like. Okay, so let's start doing this. All right, so we're going to start by multiplying everything in here by 3x. Or actually, you know what I'm going to do? I'm going to start with the x squared and multiply that by these two things first. So we'll go x squared times 3x, and then we're going to multiply, and we'll go plus, and we're going to multiply it, x squared times -4. All right? So I multiplied this by both terms in here. Now we're going to move over to the 7x, my bad, 7x times 3x. The reason this is a good order to do it in is because it puts things in order for you, and it's a lot easier to collect like terms. Right now that we've done our 7x, let's do 12. So plus 12x, or 12, sorry, times 3x, and then plus 12 times -4. You notice I always put a plus in between them regardless of like the sign here, and I just include that sign with the term, and we'll adjust that later. So we have x squared times 3x, so you get 3x cubed, all right? And then we have minus 4x squared, and then plus 21x squared. All right, so there are my x squared terms. We have minus 28x and then plus 36x. So there's my x terms. And then you have minus 48. And so when we simplify this, we get 3x cubed plus 17x squared plus 8x minus 48. All right, and so for domain and range, right, we're gonna use the same set notation. I'm not gonna write the d today. I'm just gonna go equals, all right, and then put my curly brace. Okay, so for every x, all right, again, all real numbers. There's really nothing that we can exclude from this, right? Everything should work, right? And now for range, this is going to be kind of interesting because it's not what you're going to expect. Now, let's take a look at this on Desmos, right? So I should probably make sure I got everything pulled up here, right? So here we go. Here's Desmos, and this is not the function we want, right, at all. So on Desmos, all right, it'll let me, okay? So we're going to go, let's call this j of x. So j of x is equal to, and we have 3x to the third power plus 17x plus 8x minus 48. Okay, so we've got this absolutely, or you know what? I missed something here. We need a square here, don't we? Mr. Simons, you're falling apart. All right, so that's kind of what we got here. Let's see if I did that right. I can't remember if it was supposed to be negative. No, it's positive. 3x cubed, 17x squared, 8x, -48. Yep, there we go. All right, so we got a classic cubic-looking function here. It looks like it starts down at the bottom, it comes up, boom, goes back down a ways, and then comes back up, and its end behavior is the opposite going either way. And that's what's kind of important here. Because if the end behavior is the opposite going the other way, that means that this thing, there aren't any values that this doesn't take on for y, right? It'll eventually hit all y values. So because of that, because our outputs are going to include everything, this is all real numbers, just like this one, right? And so the rule that you can kind of remember is you look at your degree, right? And your degree is the exponent that is on the variable with your leading coefficient, right? So this is your leading term, right? And your leading coefficient is 3. So the exponent's 3. So when you have odd degree functions, all right, when you have odd degree functions, your range is always going to be all real numbers, all right? And when you have even degree numbers, right, or functions, even degree functions, so x squared, x to the fourth, right, your range is pretty much always going to be conditional, right? So it's going to be dependent upon where the vertex is and how stuff like that works with one of your curves. And it's not going to include everything. It's going to be conditional. But for odd, which this one is because it's the third power, it's always going to be all real numbers. So that's kind of a nice little hack that you can carry with you and sort of remember. There's a lot to be said by analyzing and learning some of the tricks associated with just the leading coefficients and the starting terms of these functions, polynomials, right? So yeah, all right, I'm going to stop, and we'll see you in the next one.